Hello Chem 107 students, we are back for our fifth video for chapter 10. It is a long chapter, and we're going to start by writing these reactions. We have alpha, beta, and gamma decay or emission reactions to do. Now notice I gave you the symbol and the mass number of your starting parent atom, like the alpha decay of PO210. So what's the bottom number? Because we need a top and a bottom number. Well, I want to show you how to get that. First of all, we have to find PO on the table. So we look for PO, and here it is. It's number 84. That's the bottom number. So we're going to start 210 over 84 PO, and then do alpha decay. So maybe you needed that help to get started. So I'm going to let you pause now and write your reactions on your own and then check with me in a minute. So hit pause. Okay, welcome back. So I hope you paused and wrote the reactions. So alpha decay of polonium-210. Again, we found PO on the table and it's number 84. So we're going to start with 210 over 84 PO. What comes next? Next is an arrow, This is alpha decay. What is alpha? What over what? I hope you said 4 over 2, alpha. And then you figure out the daughter atom. Okay, I'm going to wait a minute to show the answers. Let's look at the next one. Beta decay of carbon-14. Again, I gave you the mass number 14, not the bottom number. So we have to find carbon. Here it is. It's number 6. So you should have 14 over 6 carbon. What comes next? Arrow, an arrow. And then we need beta. What is beta? What over what for beta? 0 over minus 1, beta, and then you figure out the daughter atom. Okay, I'll show you the answer in just a minute. Last one, gamma decay of CO60, that's cobalt. So we have to find CO. Here it is. CO is number 27. So we're going to start out 60 over 27, C with a little o, cobalt. What comes next? Arrow, and it's gamma. What is gamma? What over what? Yeah, this is the easy one. 0, 0, gamma. 0, 0, gamma. And then you figure out the daughter atom. All right, so let me show you your answers. Here they are. Let's look at the first one, the alpha decay. We start with 210 over 84 PO, arrow, 42 alpha. Now remember the top numbers have to add up. 210 equals 4 plus 206. 206 plus 4 is 210. Bottom numbers, 84 equals 2 plus 82. 82 plus 2 is 84. All right, so that's the first one. Hopefully you got that right. Now let's look at the beta decay of carbon-14. 14 over 6 carbon, arrow, 0 minus 1 beta, plus 14 over 7 nitrogen. Let's add up those numbers again. The top numbers, 14 equals 0 plus 14. 14 plus 0 is 14. Then we have 6 equals minus 1 plus 7. 7 minus 1 is 6. And number 7, again, you have to look up the 7 and see its nitrogen. Just like for the first one, you looked up 82 and saw that it was PB. All right, last one. 60 over 27 cobalt, arrow, 0 over 0 gamma, plus 60 over 27 cobalt. It's the same thing, right? 60 equals 0 plus 60. The bottom numbers, 27 equals 0 plus 27. All right, if you didn't quite catch the alpha, beta, and gamma, I am going to make another video specifically for writing these reactions for your lab. Okay, so watch for that video. All right, let's continue on with our PowerPoint. Next up, we're going to talk about radioactivity in you. So ionizing radiation, alpha, beta, gamma, and X-rays, have enough energy to ionize molecules they hit, which can kill the cells or cause them to mutate into cancer. Or sometimes they just die, or they can repair themselves. So it doesn't always result in cancer. But the ionizing radiation is alpha, beta, gamma, and X-rays. So these types of radiation can be used to kill cancer cells, right? So we can actually turn the tables and use these ionizing radiations to kill cancer cells if we can target the cancer cells, not the good cells, just the cancer ones. Now, the side effects of doing this is called radiation sickness. This is where you feel bad, you may lose weight, your hair falls out. Okay, so we need to protect ourselves from ionizing radiation. We do that with lead shields, like when you go to the dentist and they're going to take an x-ray of you. The technician doesn't want to be exposed to the x-rays every day, so they go behind the wall where there's lead in the wall, or the wall is thick enough with concrete, or they put on a lead shield. Sometimes they put a lead shield on you so it doesn't hit the rest of your body, it just hits your face. Now, nuclear medicine. So nuclear medicine is a medical specialty involving the application of radioactive isotopes in the diagnosis and treatment of disease. So sometimes we use ionizing radiation to diagnose something, like a thyroid scan, or sometimes we use it to treat a disease, like chemotherapy. So nuclear imaging uses very small amounts of radioactive material to diagnose, evaluate, or treat a variety of diseases. So these do include many types of cancers. Sometimes we can treat and diagnose heart disease, gastrointestinal problems, endocrine or neurological disorders, and other abnormalities. As an example, xenon-133, that's the mass, is inhaled to go into your lungs to diagnose respiratory problems. So healthy lungs uptake xenon readily, but bad tissue in the lungs won't. So we can take an image of that and see which part of your lungs are healthy and which are not. Another example, iron-59 is used to diagnose anemia. And another one, iridium-192 beads are injected to destroy breast cancer cells. So there's many different ways we can use nuclear isotopes in medicine. Here's another table with some uses. Cobalt-60 can be radiation therapy to prevent cancer. Iodine-131 can locate brain tumors, monitor cardiac, liver, and thyroid activity. Carbon-14 studies metabolism changes for patients with diabetes, gout, and anemia. Carbon-11, you can tag it onto glucose to monitor organs during a PET scan. Sodium-24 is used to study blood circulation. Thallium-201 can be used to determine damage in heart tissue and detect tumors. Technetium-99M, M means it's a gamma emitter, by the way. Locate brain tumors and damaged heart cells, can be a radio tracer in medical diagnostics, so we can image our organs and blood flow studies. So those are just some of the uses of radioactive isotopes. Now what I want to talk about in the next video is medical images. This will be our last video for Chapter 10. All right, goodbye 107 students. One more video to go. Good luck.